of this video is for you to understand and to learn the difference of alkanes, alkenes, alkynes, and aromatics.
Hi, today we're going to talk about an important topic, which are the organic compounds. And to understand this topic better, you should know what is UPAC, and this is the International Unit of Pure and Applied Chemistry. It serves to advance the worldwide aspects of the chemical as science and to contribute to the application of chemistry in the service of humankind. As a scientific, international, non-governmental, and objective body, UPAC can address many global issues involving the chemical science. The most common hydrocarbons are methane, which is our source of termites, cows, and natural gas. The ethane the source is natural gas decomposing plant material. Another one is ethene, and the source is ripening fruit. Another one is propane, and the source is natural gas and decomposing plant material as well. The importance of these lies in the fact that they are the basis of plastics, lubricants, paint, textiles, medicines, and also work to generate electricity. We cannot ignore the role of oil in the development of everyday life, as it is through them that we can perform our daily activities. Are used as fuel and solvent, including gasoline, thinner, butane gas, using stoves, methane, the main component of natural gas, and
hydrocarbon is a compound made of nothing more than hydrogens and carbons. It is possible for double or triple bonds to form between carbon atoms, and even for structures rings to form. Saturated hydrocarbons have only single bonds between adjacent carbon atoms, and unsaturated hydrocarbons have double or triple bonds between some of the carbon atoms. The main classifications of hydrocarbons are alkynes, alkenes, alkenes, and aromatics.
To name alkalines based on the UPAC system are: first, find and name the longest continuous carbon chain. Second, identify and name groups attached to this chain. Third, number the chain consecutively, starting at the end nearest of a substituent group. Fourth, designate the location of each substituent group by an appropriate number and name. Fifth, assemble the name listing groups in alphabetical order using the full name. We need to know that there are three types of hydrocarbons: alkane, alkene, and alkyne. Alkane have single bonds, alkenes have double bonds, and alkynes have triple bonds. We have these hydrocarbons since there are 4 carbons. Its prefix is but, and there are only single bonds, so it is alkane. So this hydrocarbon is butane, and its formula is CH3, CH2, CH2, CH3.
Well, here they are, two more examples of naming alkenes. In this case, it is 3-methylpentane because it has a carbon chain of 5 and the alkyl group is in the 3rd carbon. And here is 2-dimethylhexane because it has a 6 carbon chain and it has 2 alkyl groups of methyl.
Hydrocarbons, there are 5 carbons. Its prefix is pent. And we can see here a double bond, so it is alkene. So this hydrocarbon is pentene. It is a 2-pentene because the double bond is in the 2 carbon. And its formula is C5H10.
Now here we have two more examples of naming alkenes. This alkene is named 4-methyl 1,3-pentadiene. It's 4-methyl because here is the alkyl group, is 1,3 because it has a double bond in the first and then in the third carbon, and is pentadiene because it has 2 double bonds. Then here is 3-methyl 2-pentene because in the third carbon there is the alkyl group, and it is a 5-carbon chain with just 1 double bond.
First, we identify the longest chain, and we have 5 carbons. It is a pentene. It is a 2-pentene because a triple bond is in the 2 carbons. And then we find a carbon alone. It is a methyl, and it is located on the 4th carbon. So the name of this hydrocarbon is 4-methyl 2-pentane.
Now we have 2 more examples of naming alkynes. In this case, this alkyne is named 2-butene because in the second carbon we have a 3 bond. Then this is 4-methyl 2-pentane. It is 4-methyl because in the fourth we have an alkyl group, and 2-pentane because in the second carbon there is the triple bond.
An aromatic hydrocarbon is a hydrocarbon with alternating double and single bonds between carbon atoms forming rings.
Well, naming aromatics, in this case, this aromatic is 1-ethyl 3,5-dimethylbenzene. It is 1-ethyl because first is in alphabetic order. It is the ethyl that is here, so it's 1, 2, 3, 4, 5, 6. So it's 3,5-dimethyl and benzene because it's an aromatic. Then is P4-ethane 1-propane benzene. The P is because it's in the other side. Then is ethane because here it is ethane because it's in alphabetic order as I said, and propane because here's the propane. Benzene as the same is because it's an aromatic.
Today we are going to see how to draw alkanes. First, we need to know the different kinds of alkanes. They vary by the number of carbons there are. For example, this one has only 1 carbon, so it's called methane. This next one has 2 carbons and has hydrogens connected to 3, so it's called ethane. What in the name makes you think that it's 1 carbon? Met means 1 carbon and et means 2 carbons. And what gives the name? The classification of alkanes, aside from only using single bonds in the structural formula, it's the name ane at the end of the word. Another example is this one, using only 3 carbon. This structural formula is called propane. And prop as in 3 carbons, and ane as an alkane. Another example is pentane using 5 carbons. Pen meaning 5 carbons, and "ane" at the end gives you that the classification of as an alkane. Now we're going to see an example of how to draw the structural formula of an alkane. The name is 2-bromo 2,5-dimethylhexane. First, we need to analyze the name. What can give us a clue of what the main chain is going to be like? Hexane. So there's going to be only 6 carbons in the main chain. Notice that at both ends of the main structural formula there's going to be CH3, and where it branches it's going to be CH, and all of the rest are going to be CH2. Then we have to number them from right to left or from left to right. Now we see the name 2, 5. So in the number 5 we add CH3, and in the number 2 we add CH3, and also in the 2 we add a bromine from the 2-bromo. So 2 and 5.
I'm going to explain what are alkynes and aromatic compounds. Alkyne compounds are those compounds that have more than one triple bond. It can have 2 triple bonds or even 3 triple bonds, it doesn't matter. It needs at least more than 1 triple bond. And those aromatic compounds are the ones who have benzene on it. It's really simple. Those are the hexagonal one. And I'm also going to explain how to draw condensed structural formulas. The first step is to draw the main chamber of carbons. If it's methane, it's just 1 carbon. If it's butane, well, you write the amount of carbons butane have. The second step is to add the substituents according to the name. If it tells you that it has methane on it, you have to place methane on it in the carbon. I mean, if it's 3 methane, you go to the 3rd carbon and place the substituent on it, and you do that with all the substituents on the formula. And the third and final step is to add the hydrogens on each carbon to form 4 bonds on each carbon. If there's a carbon who already has a bond and there are 3 missing, you have to add 3 hydrogen. If it has 2 bonds, 1 on each side, you only have to add 2 hydrogens. And if it has like 3 bonds, you only need to add 1. If it already has the 4 bonds, you don't need to add any hydrogen because there's no space available for the carbon to have another hydrogen. It's really simple, and once you've got the idea, you will know real fast how to draw and even how to name those condensed structural formula.
Well, now we'll see the condensed structural formula for 2 more examples of alkenes. This alkene is named 3-ethyl-2-pentene. The structural formula will be like this, because 3-ethyl, because in the number 3 we have an ethyl alkyl group because it has 2 extensions. Then we have a double bond right here That's why it's pentene, 2-pentene, because this is the second carbon, and it is 5. And then 2-methyl 2-butene, because in the second carbon we have an alkyl group, and in the second carbon too we have the double bond. Then it is 4-carbon chain, that's why it's butene. So we have 2 more examples of condensed structural formula of alkynes. This is 2-pentyne, because the triple bond is in the second carbon, and this is 1,3-hexadiene, because it has 2 triple bonds in the first and in the third carbon.
Hydrocarbon derivatives are compounds made of carbon atoms and at least one other atom that is not hydrogen. Functional groups is a special arrangement of atoms that is mainly responsible for the chemical behavior of the molecule. Functional groups also determine some of the physical properties of the molecule. When one or more functional groups are attached to a hydrocarbon, the resulting compound is referred to as a hydrocarbon derivative.